Hello, and welcome to Intercepts and Graphing. This is an intermediate algebra approach to the topic. Let's get started. So, there are many different ways we can write the equation of a line. In an earlier video, we saw the slope-intercept form of the line, and today we're going to talk about the general form of a line. And the general form of a line, let me get set up here, is of the form ax plus by equals c, where a, b, and c are integers, and a is non-negative. So a cannot be negative. It could be 0, it could be positive, but it cannot be negative. And the reason for this is typically because a negative to start the equation is so easily lost that we prefer not to do that, because negatives, we know that's the hardest part of math, is just losing negatives. So let's rewrite the following equations in general form. So first of all, we notice in general form that all the x's and all the y's are on one side of the equation, so both variables on the left, and just a constant on the right. So the first thing I'm going to do is I'm going to subtract 2x from both sides. And when I do so, I get negative 2x plus y equals 10, which looks amazing, except a cannot be negative. So I'm going to divide everything by a -1 to get 2x minus y equals a -10. That was really poorly written description, but negative 2x plus y equals 10. I need this x to be non-negative, so I can multiply or divide every single term by a negative in order to change its sign. Another thing we need to keep in mind, let's wait a minute on that. Again, so we're going to subtract the 1/2 x from both sides. But something that we also need to keep in mind is not only is the negative, they have to be integers. Integers are our positive and negative counting numbers along with 0. So no fractions, basically no fractions. So in order to get rid of the denominators, I have a 2, I have a 7. That is a common denominator of 14. And what I'm going to do is I'm going to multiply -14 times everything. Everything, even if it doesn't have a denominator. Because if I multiply one thing by 14, in order to keep the balance in the equation, I have to multiply everything by 14. So since I chose a -14, negative times negative is positive. 1/2 of 14 is 7x. -14 times y. And 7 goes into 14 twice. Let's make a note of this. 7 goes into 14 twice. Now I'll have a -4 times a -2 to get a +8. And I have the general form of an equation of this line. All right. It seems like all of my problems are kind of the same form, so I'm going to subtract 3x. I'm going to divide everything by a -1 to get 3x minus y equals 15. And this last one, I want you to hit pause and give this one a try on your own. Like seriously, it's 4 minutes, hit pause. Now that you're back, let's see how your answer looks compared to mine. -1/5 x plus y equals 3/8. Again, we have fractions. We can't have fractions. They have to be integers. And a has to be a non-negative integer. It doesn't have to be positive. It just has to be non-negative. So if I look at all my denominators, I'll need a 5. I'll need an 8. So I'm going to multiply -40 by every single term. And parentheses are actually a really good idea. That way our negatives don't get mixed up somehow. Let's take this over in blue. A negative times a negative is positive. 1/5 of 40 is 8x minus 40y 8 goes into 45 times. So 3 times a negative 5 is negative 15. All right, so if you actually paused and you tried this on your own, you did awesome, didn't you? It's because you know how to do this. Good job. All right, so intercepts. Intercepts are always a point on an axis. In order to find an intercept, we could set the other variable value as 0 and solve. All right, so to find an intercept, we set the other value as 0 and solve. Wait, what does that even mean? Let's see if we can... I don't want that. I was just kidding. I don't want that. There we go. Let's see if we can insert a little line here. Let's think about this. If I have a coordinate axis, here's my x-axis, and if I have a point on the x-axis, notice there it did not go up, it did not go down. My y value is 0. Similarly, if I have a point on the y-axis, I did not go right, I did not go left, my x value is 0 for a y-intercept. So anytime we're looking for an intercept, we set the opposite value to 0. So let's check it out. I'm going to take this problem all the way to the next page so we can see it all together. Here we go. Find the vertical and horizontal intercepts. Explain their meaning in the given situation. Remember, horizontal comes first. Horizontal is input, is x values, and vertical is your output. It's normally going to be your y-intercept. Okay, alphabetically, still input, output, horizontal, vertical, x, y, top, bottom, numerator, denominator. They all go together alphabetically. Okay, now we know, given let d equal 0.28t plus 5.95 be the percentage of adults aged 18 years old and over in the United States that have been diagnosed with diabetes t years since 2000. What we know is that our vertical intercept, since this is given in slope-intercept form, is 5.95. So what that means when t equals 0 is in 2000, in the year 2000, there were 5.95% adults with diabetes aged 18 and over. I don't think we have any adults aged 17 or younger. I'm just saying. But in order to find our horizontal intercept, all right, we use t equals 0 to find our output, our vertical intercept, our horizontal intercept. Now we're going to make d0 and we are going to solve again. I have a little backwards action going on there. We all have our struggles here and there, so even your professors do. Let's subtract 5.95 from both sides. We could divide both sides by a 0.28. And we find that t equals, let's pull up our calculator here. Clear what we had before. We have a negative 5.95 divided by 0.28, which gives us negative 21.25. Now, this does not make sense in the given situation. What this actually says is 21.25 years before 2000, so we're looking at 1979. That's close. 1978 and a quarter. So in 1978, around 3/4 of the way, month 9, September, there were no adults with diabetes, diagnosed with diabetes. And we know this is incorrect. This is a model breakdown. So our models don't necessarily always model the data. They might just model it for a few years. They might model it over a course of a decade. But in general, if we extend our timeline forever, the models do break down. All right, so the pressure inside a vacuum chamber can be represented by P equals 35 minus 0.07 S. P is the pressure in pounds per square inch of the vacuum chamber after being pumped down for S seconds. Our vertical intercept, which we know will be our P intercept, that's when S is 0. When S is 0, our P value is 35. So this vertical intercept says the pressure inside the vacuum chamber starts at 35 psi. Notice each time I put my intercept, I label it. What is it? It's percentage with diabetes. It's psi. It's in a year, right? I transform my T into an actual year. So keep that in mind. Our horizontal intercept will have P equal to 0. All right, so we're finding our S. S's are hard for me. They sometimes look like 5s, but let's give it a shot. So I'm going to subtract 35 from both sides. No, I'm not. Let's not be negative. Let's instead add 0.07 S to both sides. When we divide by 0.07, so that's 35, divided by 0.07, 500. And what does this mean? What this means is, after 500 seconds, the pressure, URE, will be 0. All right, so it takes 500 seconds to release the pressure inside the vacuum chamber. All right, let's make some tacos. Before we make tacos, I'm going to, hopefully, I forgot, there we go. Put that on another page. Let's look at tacos. Let's draw. The cost for making tacos at a local taco stand can be represented by C equals 0.55T plus 140. C is the cost in dollars to make tacos at the neighborhood taco stand when T tacos are made. So my vertical intercept, that's always our output. And that tells us when our input is 0. T is tacos, not time in this case. And we know that our C value is $140. So it costs $140 to just open the stand with no tacos. I happen to live in Las Cruces, New Mexico. If there was a taco truck or a taco stand and they were out of tacos, I could tell you we would all be upset, especially if they were good tacos. All right, T is going to be our horizontal intercept, always the input. Horizontal intercept. So we're going to make our costs 0. Let's see. The horizontal intercept in slope intercept form is always the one that takes a little bit more time, a little bit more work. So let's subtract 0.55T from both sides. Let's divide by 0.55. Let's divide by the negative as well. And let's take out that extra 0 that I just felt I needed for some reason. And we end up with t equals, over to the calculator, 140 divided by a negative 0.55. And we end up with negative 254.54 repeating. Now what this says is, in order, maybe we'll throw an R in there, in order to have no costs, they must make negative 245 tacos. And that's a big question mark, right? This is, again, a model breakdown. You're always going to have costs associated with a creation of something. It costs something to make something. So intercepts don't always have a place in real world situations, but they are something that we could talk about because the math of them still works out, even if the representation does not. All right, let's keep going here. I'm going to kick that off for a minute. Bring this up. I am not going to do that. I'm going to go ahead and throw that on the next page. Here we go. Find the vertical and horizontal intercepts and use the intercepts to graph the lines. I'm thinking that, looking at the time, it's time for a part 2. I'm going to put this in part 2. We'll leave the word problems in part 1. That's it for now. Stay tuned for part 2.